So food for thought. Just visualize that periodic table. Scientists have seen the stability of elements, which means which group has showed the inactive nature, which group has no response towards chemical reactions. And they came to know the last column, the noble gases, the rare gases, zero group, eighth element, helium family, right? Inert gases, these, the last column, have no interest in taking part chemical reactions. So these are the most stable elements. Now scientists thought that what is the reason of their stability? Why they do not take part in chemical reaction? They came to know they have their shells complete, their outermost shells are complete. For example, helium, its atomic number is 2 electrons, which are there in the second shell, in the first shell K, and we know that K can hold just 2 electrons. So the shell is complete. After just below helium is neon, atomic number 10. Out of 10 electrons, 2 in the first shell, K2, 8 in the second shell, and we know that second shell can hold maximum 8 number of electrons. Again the shell is complete. Just below neon it's argon, atom number 18. So 2 electrons in the first shell, 8 electrons in the third one, and so on. So their octets or duplets are complete. So when their duplets or octets are complete, that is why they are considered as noble gases or inactive gases. Right? So what is the reason for their stability? Because their duplets or octets are complete. Clear? Now for rest of the elements of the periodic table, these noble gases are considered as role models. Remember, except helium we can use the term octet, but for helium we will use the word duplet. We will use the word duplet. So there is a term called valency. What is valency? The combining capacity of an element. Means it will tell you that how many electrons can be shared or lost or gained by an element. Okay? For example, CH4, yes, you know it is the formula of methane or methane, whatever you say. How many hydrogens are there with one carbon? 4. It means carbon can combine with 4 different hydrogens. So what is the valency of carbon? What is the valency of carbon here? 4. We call carbon as tetravalent. NH3. What is NH3? Ammonia. In this ammonia, how many hydrogens are here with each nitrogen? 3. So we can say that the combining capacity of nitrogen is 3, because it can accommodate, it can link, it can produce how many? 3 hydrogens to produce ammonia. H2O, what is the combining capacity of oxygen over here? 2, because it can combine with two hydrogens. In HCl, hydrogen chloride or hydrochloric acid, what is the combining capacity? What is the valency of chlorine? 1, because chlorine can combine only with one hydrogen. So we are studying this valency with respect to hydrogen. Okay? So what is valency? The combining capacity of an element. Why do we consider hydrogen here? Because hydrogen itself is considered as 1. Hydrogen is considered itself as univalent. So if this is carbon, then it can combine with 1, 2, 3, 4. So what is the combining capacity of carbon? 4. With ammonia, if this is nitrogen, it can combine with 3 hydrogens. So the combining capacity of nitrogen is 3. If this is oxygen, the combining capacity of oxygen will be 2, because it is combining with 2 hydrogen. If this is chlorine, its combining capacity would be 1, HCl. That's okay.
State. Okay, and that's pretty much going to be the key of this lesson. We're going to be looking at the valence shell and the importance of it being full. Okay, so let's look at sodium. Sodium, or let's look at the atomic number. The atomic number is 11, which means our protons to electrons count have to be 11. So let's draw a Bohr diagram. So we start off with a symbol, and we need to fill in the electrons. So we need to fit 11 electrons. 2 can fit in the first shell, 8 in the second shell. We have a total now of 10 electrons, and which means it has 1 valence electron. And that valence electron we know because it's in group number 1. So now, for sodium to become stable, it needs to do one of 2 things. It can either lose 1 electron or gain 7 electrons. So most likely, energetically, which one's more energetically favorable to sodium is to lose the 1 electron. So let's say bye-bye to that valence electron. There it goes. But now the count here that we have, positives to negatives, is no longer the same. Now watch the change. We have 10 negatives, which means we have more positives than negatives. How many more positives? Well, we have a total of 1 extra proton, which means now sodium carries a charge of +1. Magnesium, atomic number is 12. Again, 12 protons, 12 electrons. So let's start off by writing in the symbol. Mg, 2 electrons of the 12, another 8, because 8 can fit in the second. So we have a total of 10 electrons, which means we have 2 valence electrons. And magnesium is part of group number 2. So for magnesium to become stable, it has also one of 2 options. It can lose 2 electrons or gain 6 electrons, because there's a total of 8 that can fit in that shell. So most likely, which is more energetically favorable? Well, to lose 2 electrons. So let's say bye-bye to those 2 valence electrons. There they go. And now our proton to electron count is no longer 12 protons, 12 electrons. It is 12 protons and 10 electrons, which means now magnesium is no longer neutral. Magnesium has a surplus of 2 protons. Okay, so notice here 2 protons. Why? Because the count is a difference of 2 extra positives. Okay. So now let's look at the opposite end of the periodic table. We have fluorine, and fluorine has an atomic number of 9. So which means 9 positives, 9 negatives. Okay, start off with a symbol, start off with the letter F. And we need 9 electrons, so 2 in the first shell and 7 in the final shell, total of 9 electrons. Now, for fluorine to become stable, it needs to do one of 2 things. It can either lose those 7 electrons or it can gain one electron. And most likely it will gain an electron. So there it is. It just gained. So let's just watch that again. We're going to gain one electron. Here it comes in. Okay, odds are it probably came in from one of the metals. Now, look at the positives to negative count. Now we no longer have a surplus of positives. We have a surplus of negatives. Okay, we have 9 positives and 10 negatives. So 9 protons, 10 electrons. So fluorine has an excess charge of -1. Okay. Sulfur. Let's look again. We are to the right of the periodic table. The atomic number of sulfur is 16. So our positive proton to electron count is 16 to 16. We start off with a symbol, and we need 16 electrons. 2 on the first shell, 8 on the next shell. We have a total of 10, and we are now in group 16. And so now we are putting in the rest of the electrons. So we have 16 valence electrons. Now, for sulfur to become stable, it needs to do one of 2 things. Lose 6 electrons or gain 2 electrons. And most likely, it will gain 2 electrons. And there they are. Now, let's look at the proton to electron count. 16 protons, 16 electrons, but now we've added 2 more electrons. So now our count is 16 protons, 18 electrons. We have a surplus of 2 extra negatives.
So here you can see a rough values of valencies of different elements. Group 1. If someone asks what is the valency of group 1 element, what are the group 1 elements? Because you can see on the screen lithium, sodium, potassium, rubidium, cesium, francium. These are the elements of the group 1. Let's take an example. Lithium. Atomic number of lithium is 3. So 2 electrons in the first shell. The second shell, how many electrons it has? Just 1. So to satisfy its valency, it has 2 different options. Satisfies valency means to have octet, to have complete octet. So there are 2 possibilities, octet or duplet. Either it gets rid of that 1 electron and become a satisfied duplet. What is the one way? That lithium has 1 electron in its valence shell. It can give 1 electron to the other. And what is the other way? Instead of losing 1 electron, gain 7 more electrons from. If it takes 7 electrons, it would be -7. So -7 is not practically possible. So the only way for lithium is to lose electron. That is why we say that the valency of lithium is 1 plus 1. Why plus 1? Because it is becoming a contented element, and it is becoming an element of satisfied valency after losing 1 electron. So its value is plus 1. You must be remembering that if an atom loses electron, it will acquire a positive charge. If it gains 1 electron, it will acquire a negative charge. Okay? Just below lithium is sodium. What is the atomic number of sodium? 11. So 2 in the first shell, 8 in the second shell, and in the third shell just 1. Again the same problem. Either it gives 1 electron or it takes 7 electron. So it gives 1 electron. So the valency of sodium is also 1. Same is true for potassium just below lithium, sodium. It means all the members of group 1A, they donate 1 electron to have their complete duplet or octet. That is why we say the valency of group 1A is +1. Okay? Theoretically you can say it could be +1 or -7, but practically it is +1. Now see another group. What is that group? Beryllium, magnesium, calcium, beryllium. Now let's start with beryllium, or rather start with magnesium. What is the atomic number of magnesium? 12. So 2 electrons in the first shell, 8 electrons in the second shell, 2 electrons in the last shell. So last shell should have how many? 18 electrons, whereas it is only having how many electrons? Just 2. Right? Again the same problem. Octet is not complete. So there are 2 options. Either gives 2 electrons, removing the 2 electrons. What is the other way? To gain 6 electrons. If it gives 2 electrons, it will become +2, and they will have now complete octet. Or the other way, take 6 electrons to have complete octet -6. -6 is not possible, so the valency of magnesium is +2. Alright, just below magnesium, the next is calcium. What is the atomic number of calcium? 20. What is the atomic number of calcium? 20. So let's see how many electrons it will have in the last shell. Just 2. Same problem. So we can say that all the members of group 2A, they can lose 2 electrons. That is why their valency will be +2. Group 3A, the first member is boron, the second member is aluminum. Here you will find 3 electrons in their valence shell. So they will have 2 options, either give 3 electrons to become +3, or to take 5 electrons. So 5 is not possible to take. So that is why the valency of these elements, the elements of group 3, is +3. Let's talk about another group, the last one, group 7A, fluorine, chlorine, bromine, iodine. Fluorine, atomic number 9, 2 electrons in the first shell, 7 electrons in the second shell. Now it has 7 electrons. So to have complete octet, it only needs 1 more electron. So instead of losing electron, it will try to gain 1 more electron. So its valency will be -1. So after taking 1 electron, its octet will be completed. Same is true for chlorine, just below it. It requires 1 more electron. It requires 1 more electron. So that is why the valency of group 7A is -1. Why? Because after taking 1 electron, they have complete octets. Just before it, oxygen, atom number 8, group 6A, first member oxygen. 2 electrons in the first shell, second shell will have how many? 6. To complete octet, there are 2 options. 6 already have. So it will take 2 more electrons, first option. Second option, to lose 6 electrons. So which is possible, which is easier? To take 2 electrons. So oxygen will take 2 electrons and it will acquire a -2 charge. Same is true for sulfur. It means the members of group 6 can fulfill their valencies, can satisfy their valencies after gaining 2 electrons. Just before it, nitrogen, its atomic number is 7. 2 electrons in the first shell, 5 electrons in the second shell. It needs how many more electrons? 3 more electrons. So it will take 3 electrons. So all the members of group 5A, they will gain 3 electrons. They will acquire 3 electrons. They will try to have 3 electrons. That is why the valency is -3. And here comes in the middle the carbon family. Their octet is half filled. What does it mean? Let's see. What is the atomic number of carbon? 6. So 2 electrons in the first shell, 4 electrons in the second shell. So to have complete octet, how many more electrons are needed? 4 more electrons. 4 more needed. So they have an equal possibility. That is why their valency is considered as ±4. Same is true for the other members. Carbon, silicon, all have -+4 valency. So what is the bottom line here? What is the valency of group 1A +1? What is the valency of group 2 +2? Group 3A +3? Group 4 ±4? Group 5 -3? Group 6 -2? Group 7 -1, and above all group 8, they do not take part in chemical reaction, so their valency is considered as 0. So here on the screen you can see some of the ions. Monovalent ion, mono means 1, so all of these are monovalent ions. Try to memorize them because it will help you in the future. Alright, hydrogen ion +1, lithium ion +1, lithium, sodium, potassium, they all are univalent positive ions. On the other hand, you can see univalent negative ions, fluoride, bromide, iodide, hydroxide, etc. So these are the monovalent ions or ions. Left side is positive ions or cations, right side is negative ions or anions. Here you can see divalent ions. Magnesium +2, calcium +2, zinc could be +2. Right side you can see +2, -2 for oxide, sulfur -2, etc. Trivalent, aluminum, just told you, a member of group 3. Then nitrogen, after getting 3 electrons, it will become 3-, it will be called nitride. And the tetravalent ions, just told you, +-4 carbon. So you should try to memorize these common ions, cations and anions. Alright? Now the last part of this valency, before we had this system of valencies, proper system of valency, we used 2 suffixes, us and ik. Us, there are certain elements which shows different valencies in different conditions. For example, iron shows 2 valencies, one the smaller number, the other one with the bigger number. So for a smaller number they use us, for a bigger number they use ik. हाँ बोलो. ओके, कितने बजे जाओगे? हाँ तो बंद कर दो, पहले ठंडा है कमरा. हाँ okay, so us for the smaller valency, ik for the bigger valency. For example, as I just told you, iron has 2 valencies. So for the smaller one, we will write what? Us or US, and for the bigger one, we write IC. To C, iron, Fe, Fe +2, Fe +3, these are the 2 valencies. For the smaller one we use ferrous, for the bigger one we use ferric. Tin, its symbol is Sn, it has 2 valencies, Sn +2, Sn +4. So Sn +2 is called stannous, and Sn +4 is called stannic. Similarly, mercury, mercurous and mercuric, cuprous and cupric. Alright? But with silver we will not use this us or ik, it will be called silver 1 and silver 2. It's not silverous or silveric. Now the next topic is, it is again a general topic, you should know it. It's a grade 9 level. Now how to write the chemical formula of ionic compounds. Alright? This is called crisscross method. See, what compound would form from carbon and sulfur? What is the valency of carbon? 4. What is the valency of sulfur? 2. So in the first step, we will write their valencies. In the second step, we will write one's valency as the subscript of the other. Means we will write after interchanging their valencies. Crisscross method. Okay? So the 4 of sulfur is written with 4 of carbon is written with now the subscript of sulfur. This is the same for the value of sulfur 2. I repeat. So you can see now the valency of carbon is now written with sulfur as a subscript, whereas the valency of sulfur is now written with carbon as subscript. So this is called crisscross method. Alright? If it is possible to simplify it, you can simplify it. Here you can also 2 ones are 2, 2 twos are 4. So the formula become CH2. This is the way to write the ionic compounds, the formula of ionic compound. Similarly, you can write by yourself for practice, like the first one you can see aluminum and bromine. What is the valency of aluminum? Correct, it's in the group 3. So its valency is +3. What is the valency of bromine? Member of group 7, -1. Interchanging their positions. So it will become Al1 Br3. Same is true for potassium. Potassium +1, sulfur -2, interchanging their valency K2S. Zinc +2, oxygen -2, both 2's will be cancelled. It will become zinc ZNO. Magnesium, where the magnesium is, it is in the second group, so its valency is +2. Nitrogen, its valency is -3. So it means that one should know at least the valencies of common elements. It will enhance your general chemistry, the level of general chemistry. Alright? So magnesium +2 and nitrogen -3, interchanging their places, it will become Mg3N2. What is the valency of carbon in the next one? 4. Chlorine -1. Interchanging their valency, it will become CCl4. Copper has 2 valencies. If we consider it is +2 and oxygen -2, +2 cancel. The formula is CuO. If we consider the valency of copper is 1, +1, and that of oxygen is -2, interchanging their positions, it will become Cu2O. Can you guess the name of both of these copper compounds? CuO. In this, copper is behaving as a +2 ion, so its name is cupric oxide. Whereas in the other one, copper is behaving as +1, so it will be cuprous oxide. And which is the latest way to name these such compounds? We use 1 and 2's Roman words, Roman letters we use, Roman numeric we use, like copper 1 oxide, like copper 2 oxide. If the valency of copper is 1, so instead of using cuprous, we say copper 1 oxide. If it is, its valency is +2, then instead of using cupric oxide, we say copper 2 oxide. Alright? So, the basics are in continuation. Changes. We can see two different types of changes. One, the temporary changes, others, the permanent changes. Switching on or off tube light, bulb, it's a temporary change. Or conversion of ice into water, temporary change. Why? Because we can change water back into ice by cooling it. So such temporary changes are called physical changes, whereas the permanent changes are called chemical changes, like conversion of milk into curd, conversion of paper by burning into ash. These are the permanent changes. We are becoming adult from infant, chemical change. Under ordinary conditions, it's not possible to go back to its original form. Means milk once has been converted into curd, so under curd it's not possible to get curd to convert curd back into milk under ordinary conditions. Alright? So permanent changes are called chemical changes. Examples of physical changes you can see on the book, on the screen, like boiling. When you have water, you heat it, it converts into steam. This process is called boiling. If you collect those vapors, it will again reconvert into water, so it's a physical change. Melting, you just put out a piece of ice from the freezer and leave it for some time, it will melt and convert into water. And all of us know that water can be converted back into ice. So these are all the physical changes. Sublimation, conversion of a solid directly into vapors, this is called sublimation. Freezing, condensing, deposition, evaporation, all of these are the physical changes. All of these are the physical changes. What is deposition? Conversion of vapors back into solid. This is called sublimation. Sublimation you will study in chapter number 2 also. There are certain solids which on heating converts directly into gaseous state. There is no such intermediate liquid state. So these are called sublime substances, and the process is called sublimation. Alright? All of these are the physical changes. Chemical changes, as I just told you, burning milk into curd, and talking in a more in a chemistry way, titration. When you react an acid with a base, it will form salt and water. This is an example of titration. All explosions are the chemical changes. Conversion of cement and sand into concrete, a chemical change. Next, chemical reaction showing a chemical change with the help of a sentence. This is called a chemical reaction. Okay, and chemical reaction, what do you mean by chemical reaction? It's a chemical change. And all chemical reactions they just involve the rearrangement of atoms. Chemical changes. Alright, all of these are chemical. Here we can see that when electricity is passed through water, it converts into oxygen and hydrogen. Chemical changes. So last topic it's in progress. Then from the next class we will start what? We will start the proper topics of the book. Classification of reactions. There are 4 types. All the chemical reactions can be divided according to the book into 4 different categories: synthesis, decomposition, single displacement, and double displacement. Synthesis is also called addition reaction, in which 2 or more than 2 atoms combine to form a new compound. Like hydrogen and oxygen, they form water. Synthesis reaction or addition reaction. Like carbon plus oxygen is called carbon dioxide, as you can see carbon dioxide over here. How they form? They are reacting to form carbon dioxide. So this is a synthesis reaction or addition reaction. Generally, the 2 elements can combine to form a bigger element. The reverse of this is called decomposition, in which a compound is there and it decomposes into its components. For example, NaCl can be converted back into Na and Cl. Decomposition, breakup. Generally, you can see here, if you have a compound AB, then if it breaks, it splits into A and B, we call it decomposition reaction. Usually heat is required to decompose a compound. Example you can see. Mercury oxide changing into mercury and oxygen. This is a decomposition reaction. Now single displacement reaction. What do we want displacement? To replace. So in these reactions, an atom or group of atom displaces an atom or group of atom. For example, 2 persons are sitting on 2 different chairs. Then another person comes and displaces one of the persons who are sitting on the chair. So this is called displacement. Here you can see an example that there is a solution of copper chloride, and in that copper chloride solution a strip of zinc is there. So copper will be deposited on zinc, or you can say zinc displaces what? Copper. So it means copper chloride will convert into zinc chloride, or simply you can say in such reaction one atom displacing another atom. Copper chloride, then what happens? Zinc attacks and displaces copper to convert it into zinc chloride. So one atom of zinc is displacing another atom of copper. Such reaction is called single displacement reaction. Like you have a general reaction over here, that C will replace B. Now instead of single displacement, if we have 2 partners exchanging their members, then it is called double displacement reaction. Like you can see over here, which is a partner of magnesium? O. Which is a partner of calcium? Sulfur. Now calcium will come with oxygen and magnesium will come with sulfur. So calcium and magnesium are exchanging each other. Such reactions are called double displacement reactions. AB and CD, their partners are changing here. They will become AD and BC. So what are the 4 types of reactions? Synthesis or addition reaction, in which 2 or more things combine together forming one thing. It's called synthesis or addition reaction. Which is the second one? Decomposition reaction, in which a thing is there, it decomposes. Which is the third one? Single displacement reaction, in which an atom or group of atom replaces an atom or group of atom. And what is the double displacement reaction? In which there is an exchange of partners. Two displacements were there. AB and CD will become AD and CB. That's all for today. Thank you so much. Have a quick revision and then solve the MCQs that I am giving you. I am giving the link at the bottom of this video, and you can also use different books so is that you can practice. Thank you so much. Take care.